Number three, from now on, I'm just going to factor denominators. I'm not going to factor numerators anymore. I've decided not to. Unless you guys want to keep factoring numerators. Okay. All right. Denominators, however, I still need to factor to get the LCM. Okay. Now, here's a shortcut. Yeah. Yeah. What do you think this is going to factor to? This is going to factor to probably n minus 5, n minus 2, right? So I'm going to put an n here and an n here. I'm going to put a minus 5 here and a minus 2 here. And if I use my little arches, let's see, I got a negative 5n. Yeah, you probably don't even need to do this. Negative 2n, and guess what? They add up to negative 7n. So, so there's a shortcut for you. That's your LCM. Because in this fraction, I need an n minus 5 and an n minus 2, right? In this fraction, I need an n minus 5. I already have it. N minus, but I have that too. So there we go. So then I need to distribute this, right? There's really no way to make this any easier. Yeah, we have to distribute. However, remember, this is over 1, right? Okay, so this is in the denominator, this is in the numerator, so they all cancel out. I'm left with 6. I don't need to multiply it by anything, right? So I have my 6. Yeah, I'm actually multiplying this fraction by n minus 5 and n minus 2 over 1, right? So all of these cancel, and I'm just left with 6. 6 over 1, right? Okay. Now this fraction, so I have a plus. I'm actually going to cancel out the n minus 5s. So I need 1 times n minus 2, which is just n minus 2. With me? No? Did you say no? No, no, because
Would the two be actually a positive since you're timesing it by the positive one, or is that only for negative?
yeah, here's what I'm doing. I'm taking 1 over n minus 5. Okay, there's my fraction, and I'm multiplying it by n minus 5 times n minus 2 over 1. Okay, because I'm multiplying it by my lowest common multiple. You see that, Sierra? I'm taking the 1 over n minus 5 and I'm multiplying it by my LCM. And what happens is the n minus 5s cancel. So I actually only have, now if I wanted to put parentheses around this and the 1 there, okay? And because my sign stays the same, Aiden, that's a positive 1. If that was a minus 1, then I would have to change the sign. Okay. All right, and then equals. Now I'm going to do the same thing for this fraction. Let's see, I'm going to this time cancel out the n minus 2, so I'm going to have to multiply that 4 by n minus 5. You with me, Ethan? You look confused. You good? Sure. Doesn't sound very convincing. All right, let's clean this up now. Now it's a pretty simple algebraic problem, right? We don't even have n squared. So I have 6 minus 2 is 4 plus n equals, and I got to distribute this 4 times n, 4n, 4 times minus 5, minus 20. I got to solve for n, so n has to get to one side of the equation and the numbers on the other. Yeah, I'm going to minus the n, just because I prefer to keep it positive. So I get 4 equals 3n minus 20. Now I'm going to get the 20 to the other side. Yep, plus 20 gives me 24 equals 3n. Now I divide by 3. Good, Maddie. 8 equals n. Now, remember the past couple few days,
We did check it.
we did check it, right? And I would make you guys rewrite everything and substitute an 8 in there.
But you can type
We
it.
don't have to do that, do we?
You never did. All we're really concerned about is does 8 make the denominator 0? That's what we're really checking, because that would be then it would be an extraneous solution, right? So let's look at this fraction. Does 8 make this fraction 8 minus 2? Is that a 0? No, so it works there. We're good. How about 8 minus 5? Are we good? I'm good there. We might have to,
Type that in the calculator.
yeah, we might have to put an 8 there. So we got 8 squared minus 7 times 8 plus 10. Does that equal 0? Well, 64 minus 56 plus 10. It's definitely bigger than 0.
1/5. 1/3.
1 over 3.
Yeah, I just typed it in my calculator.
So it's good. Doesn't make it 0. Now you guys going to throw things at me and stuff?
Yep.
Sure.
Everyone tie him down to the chair. We're going to throw him into the river.
You got to stone me.
No, it's
You
not.
guys watch Outlander at all? My wife's into that. We have to watch every episode. They were stoning them the other night, Sunday night. They got stoned. Let's do another one. Oh, no, you want to do number 7? Okay, we can do number 7. I was going to do number 5. I'd rather do number 5. I'll do number 7 with you. All right. Okay, number 5. Maybe I'll do it after 5. We'll see. Okay, I'm not going to worry about the numerators anymore, right? I'm not going to have you guys factor. So that's shortcut number 1, right? What's my LCM here?
3n squared.
Yeah, 3n squared. Because I need a 3n squared here. Need a 3n squared here, so I have it. And an n squared, I have that. So I'm going to distribute the 3n squared to every fraction. Okay. Now, the first fraction, they cancel out.
Same thing with the second.
So I just take the n plus 2. Don't have to multiply by anything. Equals, again, the same thing for the second fraction, right? They cancel out. So I'm just going to bring down my n squared minus 2n minus 8. And then the third fraction, well, the n squares canceled out. So I am going to have to multiply it by 3. Are you good? All right. Um, I got to distribute the 3, right? So I have n plus 2 equals n squared minus 2n minus 8 plus 3n squared minus 12. Okay, we can do some combining, right? N squared, 3n squared gives me 4n squared. Nothing to combine with the 2n, so minus 2n. But I can combine the minus 8 and the minus 12, minus 20. Okay, so I need 0 on one side.
Can't we take out like a two on the other on the right side?
We could, but I'm going to wait until I get a 0 on this side, okay? Because it might change these coefficients. So I'm going to subtract 2. Let's see, here's my numbers 2. And then I'm going to also subtract the n to get 0, right? Just keep these in line. So this gives me my 0. So I have 4n squared minus 3n minus 22. So now we can't. Unfortunately, that just kind of ruined everything for us, didn't it? And we have to factor that. That's going to be a pretty tough one, right? That is not an easy one. Remember the strategies I showed you how to factor any equation or any quadratic? You can always use quadratic formula, right? I showed you synthetic division, completing a square. What else? I know. Well, guess and check, right? Guess and check is always the easiest. Let's try that. So the factors of 4, 1 times 4, 2 times 2. The factors of 22, 1 times 22, 2 and 11. It's a minus 22, so we're going to actually be subtracting since one's positive, one's negative. So we're going to be subtracting these, but we're going to have to multiply it by a coefficient first. So there's not a whole lot here that we can do ahead of time. I'm going to go ahead and stick to my rule and try 2 times 2. So 2n times 2n. And I'm going to try the 2 and the 11.
Wait, I got 14.
14 for your constant.
Yeah.
Negative 20. Negative 12. Negative 8 is negative 20. Minus the 2. No, it's negative 22. So my outer.
Wait.
Did you see your mistake? Okay. There you go. 2n and 11 is 22n. Here's a 4n. If we subtract them, that's not going to equal negative 3n. No way. So that doesn't work. And because we use the same 2 in front of the n's, I don't have to switch them and check. I'm just going to go to the next one, 1 and 22. That's not going to be much better. That's 44 minus 2, so that's not going to work. So we know 2 times 2 doesn't work. Okay, so now we're going to have to check. Isn't this great stuff? So now we're going to have to check 1 times 4. I'm going to put the 4 there and the 1 there. Okay. Then I'm going to go back to my 2 and 11. So 2 and 11. And again, I'm going to get a huge number here, 44, so that's not going to work. But this time I do have to check switching these. So 11 and 2. This gives me 8n. This gives me 11n. And sure enough, 11 minus 8 is 3n. So there's my factors. 4n, 11, 1n, and a 2. Now, which one's going to be negative? Which one's going to be positive? Yeah, the 11, I want the bigger one to be negative, smaller one to be positive. Okay. Now I need to set those each one of those factors equal to 0. Let's see, 4n minus 11 equals 0. Add 11 to both sides. So 4n equals 11. Then divide by 4. So n equals 11. 11 fourths. And then this one's easy, right? N plus 2 equals 0. So what's n going to equal? Yep, negative 2. Okay. Now, the last couple days, I made you guys actually take this fraction, plug it in there, and made you check to see if they were equal. We're not going to do that. Okay. We're just going to see, does 11 fourths make any of these denominators 0? Well, let's think about this. N squared, so 11 fourths squared is going to be 121 over 16, so it's not 0. And we're going to multiply 121 over 16 by 3. That's not going to be 0. So that one's not going to be 0. So 11 fourths check. And since my n is always squared, I'm going to take negative 2, square it. It's going to be a positive 4. So all of these are going to be greater than 0. Guess what?
Wait,
It checks.
Yeah.
Okay. Now, if you want to go ahead and put that 11 fourths into the n and do all that work, by all means, go ahead. Because I showed you how to do it. You have those skills.
Will the 11 fourth be negative? Though?
Um,
No.
no. Yeah, because we're adding 11 and then dividing by a positive 4.
Oh my god.
Even if it was negative, it still wouldn't make my denominator 0. What do you think about them apples?
I don't like that.
That's not even.
I know, it's mine too. Yes, Sarah. Oh, I set this factor. I kind of skipped a step here. I took n plus 2 equals 0. I subtracted 2 from both sides. So n equals negative 2.
We're doing 7 next.
You want me to do 7?
Which one were you planning to do?
I was going to do 10, but I could do 7. Oh, actually, um, 7's not, well, I'll do 7. Let's do 7. That's fine. Number 7, what's going to be my, oh, we have to factor first, right? Okay, these are good. I'm only looking at the denominators. However, I need to take out a v. That leaves me with 5v minus 4, right? Right? So my LCM is going to be, let's see, my first one, I need a v and a 5v minus 4, and the rest of them I have in there. So I'm going to multiply every fraction, bless you, bless you, by the v times 5v minus 4. Okay, the 6 has everything in the denominator, so everything's going to cancel. I'm just going to be left with 6. Plus, let's see, the 5v minus 4 is canceled, so I'm going to have to multiply 1 times v, which is just v, equal, let's see, the 5v's minus 4 is canceled. I'm going to have to multiply v times v, which is v squared. Okay, I have a quadratic, so I'm going to need 0 on one side. So I'm going to subtract v, and I'm going to subtract 6. So I get my 0, and here I have v squared minus v minus 6. And this one hopefully doesn't look that bad to factor. V times v. Let's see, I have 1 and 6, 2 and 3. They're going to subtract. So 3 minus 2 is going to leave me with 1v. It's going to be 3 and 2. Want the bigger one to be negative. Smaller one positive. Set each one of those equal to 0. So here, v is going to equal positive 3, and v is going to equal negative 2. Okay, let's check the 3. 5v, so 5 times 3 is 15, minus 4 is 11. 11 times 3 is 33, so it's not going to make, this is 11, that's 11, so v is going to check. Let's try negative 2. Negative 2 squared is 4. 4 times 5 is 20. 20 minus 4 times negative 2 is negative 8, which change it to a positive. So 28, we're good there. Negative 2 times 5 is negative 10, minus 4 is negative 14. We're good there. It's going to be good there. So they both check. Unless you want to do all the work. What'd you do?
I said instead of just factoring out, I looked at the other two and just multiplied their numerators by a v because that's what it knew.
Yeah.
Presume the LCM.
It's the same thing.
Okay.
Okay. What's that, Thomas?
You have to like all of them.
Well, that was kind of a unique. Let's do number 10 while we're there. Okay, what's my LCM in number 10? Remember, this is over 1. So I need a 1. I'm going to need an R plus 1. And then this one's going to need an R plus 1, which is what I have. Okay, so I need to multiply every fraction by R plus 1. So the first one, I can't cancel out the R plus 1, so I'm going to have to take R minus 2 times R plus 1 equals, second one they cancel, so I'm just going to have the R squared plus 7R. And again, the third fraction, these are going to cancel, so I'm just left with minus 1. I have a binomial times a binomial, so I'm going to have to FOIL r squared. Let's see, r times 1 is 1r, so plus r. Inner, negative 2 times r, negative 2r. And then outer, negative 2 times 1 is negative 2. Okay. Let's see, we can combine these. So I have r squared minus 1r minus 2, and that equals r squared plus 7r minus 1. I'm going to subtract the minus r squared, and that actually gets rid of r squared. Now I'm going to bring this negative r over here just because I like to keep my variables positive. So I'm going to add 1r. So I have negative 2 equals 8r minus 1. And I'll add 2, I'm sorry, add 1 to the negative 2. Gives me a negative 1 equals 8r. And then divide by 8. So r is going to equal negative 1/8. Okay. Again, if you want to replace every single r with negative 1/8, like we've been doing the past few days, go ahead. You have the skills to do it. But I'm going to just try to reason this out because I do not want my denominators to be 0. So I'm going to stick negative 1/8 for r. So negative 1/8 plus 1 is going to be 7/8, right? It's not 0. So that checks. That checks. That doesn't even have an r in the denominator, so this is going to work. How about that for a shortcut?
I thought you said how about them out. You shouldn't use it.
I use it at home all the time.